Hello everyone, welcome back. Today is going to be lesson 214, day 2, which is going to be more transformation stuff. Our goals are to review factoring and completing the square. We also want to learn how to use the vertex to write an equation, so we'll see an example of that. That might be the only thing that's actually new in today's lesson, is if I were to give you a vertex, could you use that to help you write an equation? So that it's going to seem like a very familiar problem, but just posed in a different way. And that's what I'm going to try and do today, is just to give you the same types of problems that we've seen in the past, but maybe slightly different caveats that we need to address to get you ready for the quiz this week. All right. So we're going to start off with some completing the square here. This will be on the quiz this week. You need to make sure that you have it down. That's why I'm going over it every day and doing an example with you every day. All right, so make sure that you are doing these in the practice problems and know that you are getting them right. If not, ask me questions here. All right, so we're going to do a completing the square, and then we're going to do a factoring. So again, you'll see them side by side here, and down below the problems, you'll notice I gave you what graphing form looked like and what factored form looks like. So when we complete the square, right, we get into graphing form. So we know that at the end of our problem, we should look like this. Okay, and once we're in that graphing form, we should be able to see our vertex very easily. All right. When we factor, we get into this thing called factored form. So we know that our final form should look like this at the end. And once we're in that form, it should be really easy to see the x-intercepts. All right. So I'll demonstrate both of those, and let's see if we can get that process nailed down. All right. So here we're going to complete the square. All right. Remember, step one, we're going to take that x squared term. It goes in the upper left-hand box. All right. The middle term, this negative 2x, we're going to chop that in half. So we're going to get negative x, right? So if I take negative 2 and divide it in half, you get negative 1x and negative 1x, right? So there's my negative 2x being distributed between that first diagonal. Okay. At this point, we start building our outside dimensions. So we know that here in the upper left-hand box, we're going to need an x and an x, because x times x gives us x squared. Then down here we know we need x times something to give us negative 1x, so this is going to have to be negative 1. X times negative 1 is negative 1x. We'll repeat that over here because it's the same thing. X times negative 1 gives me negative 1x. Now I'm going to go ahead and fill in the bottom right hand box here by multiplying negative 1 times negative 1, which will give me a positive 1. It's a common mistake that students make. When you multiply two negatives, you get a positive. And I'm going to start writing my equation now that I have my outside dimensions. So recall from yesterday's lesson, since both the length and the height of this box are the same, we can write this as y equals x minus 1 squared. Since length times width will be the same thing, it's x minus 1 times x minus 1. That's where the x minus 1 squared comes from. And then to get our number over here that we're going to plus, or that we're going to add or subtract here, we have to compare what's in the lower right hand box to what's on the end of our equation. We got a positive 1, but we needed a negative 3. So I have to go from 1 down to negative 3. So to do that, I'm going to have to subtract 4. 1 minus 4 gets me my negative 3. So I'm going to subtract 4 off the end. Now when I look at that, it looks a lot like the graphing form that I described down here. So this is what we're looking for. The only question I usually get from students is, what about this a value? You can assume that the a value is 1, and we can also see that the a value is 1 in the standard form because of the 1 that we don't write in front of the x squared, right? So when we just see an x squared like this by itself, we assume there's a 1 there. So it would make sense that we're going to have a 1 here in front of the parentheses. All right. Let's write our vertex real quick. So remember, our vertex is a point, right? So we need parentheses, we need a comma separating the x and y coordinate. So remember, we can find our vertex by looking at the h and the k value. So this value tells us that our parabola has been moved to the right 1. So the vertex is going to be located at positive 1. And then the minus 4 here is our up and down, so this tells us that our parabola has been shifted down 4 units. So our vertex is going to be located at 1, negative 4. Okay. All right, let's try factoring. Right? Factoring is a little bit different than completing the square, and when we factor, we make use of the diamond. So I always refer to this as the box and diamond method. Okay, so we're going to start by taking x squared and putting it in the upper left-hand box. We then go to the -8. That -8 is going to go in the bottom right-hand box. The positive 2x here in the middle is going to get split up between these two remaining boxes, but we don't chop it in half like we did with completing the square. Instead, we have to figure out a different way to get 2x. So we need these two boxes to add to give us 2x. So I'm going to put 2x in the bottom of my diamond. The other requirement is that this diagonal that is blank needs to multiply to give me the same thing as this diagonal, which is filled in. So when I multiply this one, I get -8x squared. So I'm looking for two numbers that will multiply to -8 and add to give me a +2. So you might need to think about those numbers for a minute. You might even need to do a little bit of trial and error to see if they work, but here are the correct numbers. Okay, so if I do 4 times -2, I get -8, and if I do 4 plus -2, I get a +2. So this is how we're going to get the 2x in these two missing boxes. So I'm going to put a 4x here and a -2x here. And it does not matter what order you put those in. So you could have put the -2x here in the upper right-hand box. Now I'm going to start working on my outside dimensions. Okay, so again, we have an x squared here in the upper left-hand corner. So we know that we'll have an x times x to get the x squared. I'm going to start with this number down here. X times something gives me -2x, so this needs to be a -2. Over here we have a +4, so x times 4 gives me 4x, and then I test my two numbers here. 4 times -2 gives me the -8, so those work. Okay, so I'm going to write my equation. So y equals, and remember it's always length times height, right? So here's our height, x minus 2, and the length, or the width, is x plus 4. And you'll notice that our equation now looks like the factored form that I had described down here. Now to find the x-intercepts, we can see the x-intercepts by looking at these two numbers inside of the parentheses. If we were to set this equal to 0, because when x-intercepts occur, y is 0, we could solve this equation and figure out where the x-intercepts are located. You've actually solved this equation many times before, so we can take each of these parentheses and set them equal to 0. If I do that for the first parentheses, we would get x equals 2. If we did it in the second parentheses, we would get x equals -4. So I will have an x-intercept at 2, 0, and -4, 0. So there's my two x-intercepts, and again, you can verify those x-intercepts by graphing this in your calculator and just looking at the graph. Okay? All right, so that's your review on completing the square and factoring. So let's take a look at another scenario here. We've seen these quite frequently throughout the week, where I give you the graph of a parabola and I want you to write the equation of that parabola. The caveat is that we get to assume that the stretch factor is 1 or -1. So I give you your template, so your equation is always going to look like this, right? So the easiest way to write an equation for a parabola is to use the graphing form, because we can just pick out the information that we need from the graph. So I'm going to start by writing this out. Now remember, it says A is 1 or -1, and we can tell by the direction that the parabola opens. So in this one, the parabola opens down, so we know that A is going to be -1. Remember, the negative flips the parabola or reflects the parabola over the x-axis. I'm going to continue writing my equation now. I'm going to go inside the parentheses where we have x minus h, and to determine the h value, I look at the vertex. I notice that the vertex has moved to the left 1 unit. So that means I need a +1 inside of the parentheses. Don't forget your exponent of 2 on the parentheses. A lot of students missed that on the quiz last week. Without the exponent of 2, you would have a line instead of a parabola. Now I need to find my k value, and I can again do that by looking at where my vertex is located. Notice that my vertex moved up 2 units. So to move up 2 units, we would need a plus 2. That's the equation of my parabola. And again, you can verify this by graphing your equation in a calculator and seeing if it gives you the same parabola that you see in the picture. Alright guys, last example here. And this is kind of a new example. We've seen problems like this before where I would give you a verbal description of a parabola and ask you to write the equation. In this one though, instead of telling you what the horizontal and vertical shifts are, I have given you the vertex. So this is slightly different. Okay? So I gave us our blueprint since we know we're going to be writing our equation in graphing form. And I'm going to start writing my equation and using the clues that they give me here to fill in A, H, and K. So the first thing they tell me is that it opens downwards. If a parabola opens downwards, it has been reflected over the x-axis, so we will need a negative sign. It says that it has been vertically stretched by a factor of 9. So that means the a value will be 9. That's the number in front of the parentheses. Then I'm going to go inside my parentheses here, and I'm going to put a square on that, and I know I'm going to have an x in there, and I need to figure out what my h value is. The rest of the information that we need can actually be obtained from the vertex. So notice that our vertex is at 7, 8. Now normally, if a parabola has not moved at all, it would be at 0, 0. But our vertex is at 7, 8. So this means that our parabola shifted from 0 to 7 on the x scale. That means that it moved right 7. So I would need a minus 7 inside the parentheses to move it to positive 7. Now for the y-coordinate, we would start at 0 as well, but now it's been shifted to 8, so it went from 0 to positive 8, which means it moved up 8. So for the k value, I would put a plus 8, and that completes my equation for this parabola. Alright guys, that's it for today's lesson. If you have any questions, please let me know in the Zoom chat. Have a great day.